let's make a start on this. Evaluate this integral, giving your answer in exact form. We'll come to that exact form in a moment, but that's important. 1 minus 3x dx. Now, a few of us forgot that if we're integrating two things that are added up, we integrate them separately. So we integrate 1, and we just get, let's write in black, we just get x, and if we integrate sine 3x, well, we've got sine differentiates to positive cos, so it integrates to negative cos, so that becomes a plus cos 3x. But if we differentiate that, that becomes 3 cos sine x, so we want a third of that. Okay, we want a third of that, so then that differentiates correctly. Because of this 3x, you've got to differentiate that. It's a definite integral, therefore no plus c, Harry. Yeah, no plus c. Okay, because we're integrating it between two limits. Interesting, Harry subbed in the two limits and then added plus c at the end. Okay, so we then sub in that. Okay, and this is where the exact form comes in. So I'm going to do it in written out in full. Pi by 6 plus cos 3 pi by 6 over 3 minus, sub it in with 0. Now remember that subbing it in 0 doesn't always come to 0. 0 plus cos 3 times 0 over 3. Cos 3 pi by 6, that's cos pi by 2. Cos pi by 2 is cos 90. Cos of 90 is 0, so this is just pi by 6. And this is minus 0. Cos of 0, that's 1. So that's a third. There. Is that in exact form? Yeah. Okay. If you put it into a decimal, then that's not an exact form, because pi is not exact as a decimal, and a third you'd have to stop as well unless you wrote the recurring. Okay. Any questions about that?
Where did the 3 come from when you
this 3?
integrate? Yeah.
Okay. So if I want to do this longhand, okay, I'll do it longhand, but I really would want you to do this kind of. It becomes very tedious. Is every time you see this, you do the 3. So we're gonna let's just imagine we're integrating sine 3x dx. What I'm going to do is I'm going to do a substitution. U is 3x. So we go the integral of sine u, and u equals 3x. So du by dx equals 3. So dx is du over 3. Yeah? So it's come through the differential of that. Yeah? Okay. Any more questions? Let's go on to question 2. So find the exact gradient of the curve y equals ln 1 minus cos 2x at the point with x coordinate at pi by 6. So let's go for the chain rule not in your head, and then we can think about the chain rule in your head to begin with. So if you wanted to simplify this, u would be 1 minus cos 2x. So we've got y equals ln u. We want to find dy by dx. chain rule says that's dy by du by dx. So dy by du is differentiate ln one over u. Du by dx means I've got to differentiate this bit. Differentiate cos, it becomes negative, and remember that 2 as well. So we're going to go 2 sine 2x, and that negative becomes positive. Differentiate the 1 and it goes away. Yeah. So dy by dx is dy by du, that's 1 over u, times du by dx, which is 2 sine 2x. So that's 2 sine 2x, and u is 1 minus cos 2x, so 1 minus cos 2x. Okay, and it says find the x coordinate, find the gradient when x is pi by 6, exact, when x equals pi by 6. So we just sub in the pi by 6 into that. So dy by dx equals 2 sine 2 pi by 6 over 1 minus cos 2 pi by 6. Now, you've got clever calculators that will actually do the exact form for you, but they don't want a decimal. So pi by 6 is pi by 3, so sine of pi by 3, I need to do, if I'm going to do it properly, I need to do one of those little triangles. That's 60, or pi by 3. That's 2, that's 1, that's root 3. So this is sine, which is root 3 over 2 times 2, which is just root 3. 1 minus cos pi by 3, that's 1 minus a half. So that's a half, which gives you 2 root 3. Divided by half is the same as timesing by 2.
You need to do that step to get full marks.
No, if you just write down 2 root 3,
I meant, like, do you need to get to that 2 root 3 to get the full marks?
you do need. You can't give it as a decimal. Yeah. So. Yeah, so they want to see, I was just looking back at the mark scheme, they want to see this stage that you've obviously substituted in this, and then you can go straight to there. Now your calculators do that, okay, so you don't need to do this or this. You can just put it in your calculator and then it gives you exact form. Now I said I'd just mention the don't use the chain rule method, do it in your head methods. Okay, so from here, from looking at this, you can go y equals 1 over, ln I differentiate by doing 1 over cos 2x times by the differential of the inside. The differential of the inside is 2 sine 2x. So it is legitimate just to write that straight down, okay, without having to go via the chain rule, okay. But those people who tried to write it straight down, which bit did they miss off?
2 sine 2x.
The 2 sine 2x. Yeah, so if you're doing that and you know you're doing that, make sure you remember to multiply by the derivative. Yeah, and that's what I mean by little things. Lots of people were close, but actually those are fundamental marks, and it then means getting this mark is impossible as well. But if you think just on that question alone, you can improve your grade by quite a consistent percentage. Any questions about that? Okay, let's go on. Question 3. I thought we'd done enough on these, but not quite, it would seem. Okay.
This is an example where you had to do 1 as plus and then 1 as minus. I don't remember doing that.
The thing is, if you do,
About it, but
okay.
like, there's going to be like 4 4x, aren't they?
Yeah, but the thing is, three of them are exactly the same.
Yeah, no, I just realised.
So if you've got them both positive or both negative, they are both the same. If you take away these modular signs, you've either got to consider that it's positive or negative. Now, what lots of people did is they took them away and went, okay, the first one I can do is the easy one. I'm going to take them away and assume that it's just exactly the same. So I get 3 equals 6x, so x is 3 over 6, which is a half. Okay, and then what people did is, okay, I'm going to take them both as the negative of each. Well, if I've got the negative of each, that's effectively going to end up as exactly the same as this. So where you get one different is actually where one is negative and one is positive. I.e., if you think about these as graphs, they're both graphs like this. Okay, I'm not going to draw them overlapping deliberately, but you want to see where they overlap. Well, sometimes you might be, this is the positive bit. Well, sometimes these two positive bits overlap, but sometimes it might be a positive bit overlapping with a negative bit. Therefore, you've got to consider when minus 3 minus 2x equals positive 4x. So you've then got minus 3 plus 2x equals 4x. So you've got 2x is minus 3, so you've got x is minus 3 over 2. So you've got two solutions. Okay, some people got that, well done. Those people who sorted it out. Lots of us got the half, most of us didn't get the 3 over 2. Any questions about that? Question 4. We all struggled with this one. Okay. This is our shifting of the cos graph. Okay, we're shifting the cos graph. How are we moving it about? Well, let's just draw for ourselves a normal cos graph. A normal cos graph goes from 1 to minus 1, and it goes to 2 pi and to pi here. So, describe the transformation that has happened that has moved this graph to this one here. How much has it been moved up? 2. How many people put 3? Lots. Yeah? Okay, it's a transformation. Okay, that A is not an intercept. I know it is with polynomials, but with cos graphs, that's not an intercept. Okay, this is a transformation. So it's been moved up to. What other transformation has happened? It's been stretched in the x direction, factor 2. And are you happy that inside that does the opposite thing? Yep, so it becomes a half inside. So we get f of x equals 2 plus cos x over 2. Now, this bothered me slightly in what we're going to come and do. That x over 2, that 2 is inside that bracket. That 2 has been cosed. You can't take that 2 out until you've uncosed it. Yeah? That 2 belongs in there. Yeah? Don't try and do anything with it until you've uncosed it. There were more than one person was guilty of that in the next step. So, that's part one. Really, we probably should state A equals 2, B equals a half, just to keep the examiner happy. Part two, find f to the minus 1 and state its domain and range. So f to the minus 1, I think we're all good with this concept, that you switch it around so that you say x equals 2 plus cos y over 2. And then we undo it. Okay, first bit was fine. X minus 2 equals cos y by 2. By the way, you got method marks. If you got the first bit wrong, you got some method marks coming in here. This was where people went wrong, not everybody. What must be the next step? Somebody got it wrong, tell me. Cos. So arc cos. Arc cos, or cos to the minus 1 if you prefer that. Arc cos of x minus 2 equals y by 2, or in lots of your cases 2y. Okay, and then multiply that up by 2, so y equals 2 arc cos x minus 2. Are we happy with that? So f to the minus 1 of x equals 2 arc cos x minus 2. Tom, are we happy?
Sorry.
Henry, yeah? You sure?
Yeah.
Okay. So, domain and range, we got a little bit muddled with these. The domain and range of the inverse function. So, domain, is that input or output? It's the input. The input into the inverse function, yeah, is the output of the original function. It's between 1 and 3. Therefore, the range, and they get really fussy with the letter that you use here, the range is the output of the inverse function, and the output of the inverse function is the y values, and the y values are brilliant, the domain of the original function, the input of the original function. What was the input of the original function? 0 to 2 pi. Now, because it is an output, what letter do they want there? I think I corrected it on everyone that did it wrong. They want a y, and you actually lose a mark if you don't put a y there. Okay, because they want you to be clear that you know that those are outputs. Okay, so that's just a bit of exam technique. I don't think that's an understanding thing. Is everyone happy with that question? Lots of marks lost, but I don't think that was beyond any of us. I don't think you look at that and go, that was impossible. But it made you think. Yeah. Okay. Ready to keep going? So, spherical balloon of radius r has volume v, where v equals that. The balloon is inflated at a constant rate of 10 centimetres cubed per second. Find the rate of increase of r when r equals 8. Now, a few people went about this in various ways. I suppose the most obvious is to go dr by dt, because that's what you want, is dr by, well, what's the only other thing we're told about here? dv. So dr by dv times dv over dt. Yeah, because then the v's cancel and we get dr by dt. Now, interestingly, that wasn't the way the mark scheme did it, but this works. Okay. I'll show you an alternative way, and you can decide whether you like that. We're wanting dr by dt. Which of these do we already have?
dv over dt.
dv. How do you know you've got dv over dt?
Because it's the rate of volume increase.
It's how do you know it's a volume increase?
Because it's centimeters cubed.
Yeah, it's that centimeters cubed that is your clue that that's a volume increase. So that's my 10. What about dr by dv? Okay, it's 1 over dv by dr. So if I find dv by dr, well, I know v is 4/3 pi r cubed. So dv by dr, that becomes a 3. That 3 goes. I think that's just 4 pi r squared. So dr by dt...
Wait, how come? Oh.
3, the 3 goes. Yep, there were a few people that did some dopey differentiation there.
Probably.
Okay, so we've now got to do 1 over 4 pi r squared is dr by dt. We know what r is, so this is 1 over 4 pi times 8 squared times 10. And I think that comes out at something horrible. Who got it right? It must be 0.0124. Yeah, 0.
I didn't get any marks, and I did everything you just did.
Did you? Okay, see me at the end, and I'll add you some marks. Okay. Centimeters per second. Okay. Now, the way the mark scheme did it is they said actually they don't like this 1 over thing, so they said dv by dt equals dv by dr times dr by dt. And they said, okay, dv by dt, that I know is 10. dv by dr, well, that I know is 4 pi r squared. And dr by dt is the thing I'm trying to find out. So then dr by dt is 10 over 4 pi r squared. So we've got exactly the same thing. But just so that you look at the exam and you go, mark scheme, and you go, why is it different? That's what they've done. I think in some ways what you did is more direct, but obviously a bit more complicated because you've got this. You've got to realise that it's 1 over. Okay. Any questions about that? No. Okay. Generally, this was pretty good. This question, we did not all of us, but lots of us struggled in part 2. I think, other than a stupid rounding mistake from somebody and a not reading how much is lost from somebody else, I think we all got part 1. So if I just go over that very quickly, 1 year, so V equals 20,000 e to the minus 0.2 times 1, and that will give you 16,374.615. And so how much has he lost? It's 20,000 minus that. Equals 3.7 something. No, 3.6. 3625. So, and actually, often they don't give marks for rounding, but this one there was a specific mark. If you didn't round, you didn't get the mark, and somebody managed to round wrong. Okay, so do be careful with that. Part 2. At the same time, Brian buys his new car. Kate buys a new hatchback for 15,000. Her loses 2,000 of its value in the first year. Show that for Kate's car, k equals 0. It wasn't, it was part 3 that people got. K equals 0.413. Now, they are expecting more than just a substitution in of this. Okay, they want you to do it the proper way round. They want you to say 1500 equals 20,000 e to the minus 0.2, sorry.
E to the minus.
E to the minus kt.
So there's no 20,000.
Oh, sorry, this is just rubbish. Her car loses, so, sorry, 13,000. Sorry, that's better. 15,000 e to the minus kt. Yep. So we divide by 15,000, we get 13 over 15 equals e to the minus kt.
T is 1, isn't it?
And t is 1, thank you. So we get 13 over 15 e to the minus k. What are we going to do that? We're going to ln both sides. 13 over 15 equals minus k. So k equals, and that's where we get our 0.413. Worth noting, those people that are tempted to do the substitution and just verify, they do, particularly something like that, 3 marks, they want you to do something slightly more than just putting a number in and verifying that it works for 3 marks. Okay, so if you're tempted to do that, please do it the proper way around. How are we going? We've got time to do part 3? So part 3 said, this is, how long is it before Brian and Kate's cars have the same value? So we've got 20,000 e to the minus 0.2 t has got to equal 15,000 e to the minus 0.143 t. Okay, I think everybody wrote that down.
No, I didn't even get that bit.
Okay, does that bit make sense?
Didn't have a minus in front of the 0.143.
Okay, does it, if you look back to, it's got to be going down, therefore it's got to be a minus, because otherwise E goes up.
Yeah.
Yeah. Okay. Different people decide to take ln at different times. It doesn't matter. What matters is that you don't do anything wrong with ln. Okay? Ln at this stage, or ln once you've done the division, is the best time to do it, rather than trying to ln a division. There isn't a rule for ln A over B. Or in fact there is, that is ln A minus ln B. Okay? But you can't do e to the this over e to the this and then take ln and say that's ln of the division. Okay, it's bad. Okay, so we're just going to ln straight away. We're going to go ln, and we're going to do it all in one go. Ln of 20,000 plus ln of this. Well, ln of this is just that, equals ln of this plus ln of this, which is minus 0.143t. Yeah?
I was wondering why I was just...
Okay, and then I think it's all right, isn't it?
Yeah.
T equals 5.02, so T is 5 years. You didn't need to write the...
So can I do this paper again?
They say, okay, either prove or disprove. So that's a little bit nasty because you've got to work out firstly which one's true and which one's not true. So prove or disprove. If m and n are consecutive odd numbers, then at least one of m and n is prime. Okay, so what we're looking for is consecutive odd numbers. So let's start thinking about some. So we could think about consecutive odd numbers. So I'd probably start with 1 and 3. Not sure about 1, so I'll kind of leave that. I don't know whether that proves anything. 1 is officially prime or not prime? No, it's not prime. No, it was a few hundred years ago. It was considered prime, but they took it out of the definition of prime numbers. So a prime number must have exactly 2 factors now. That's the definition, rather than itself and 1. Okay, so we'll leave that one because that's a bit of an oddity. 3 and 5, they're both prime. So is this always going to work? 5 and 7, it is feeling good. Keep going. Okay, 7 and 9. Okay, 7 and 9. At least one of the is prime. Okay, that works. Okay, but it's feeling like if I keep getting bigger, then that's going to fail. So maybe I can go up to 25 and 27. And that's not going to work, is it? So, but it's not good enough just to write the example. You've got to show that you understand that 25 is not prime, 25 not prime, equals 5 times 5, 27 not prime is 3 times 9. Okay, therefore not true.
27 and 29.
Okay, doesn't matter what example you use. There are an infinite number of examples that you could use, but you've got to have that bit there. Okay, you can't just give the example. They're looking for some explanation that you understand what's going on. Okay, so disproving, this is a counter example. To disprove something, you need one counter example. Okay, so that was part 1. Part 2, if m and n are consecutive even numbers, then m times n is divisible by 8. Okay, so let's do the same thing, okay, to try and establish whether it's true or not, give us a feeling for whether it's true. So consecutive even numbers, 2 times 4, yeah, that's divisible by 8, 4 times 6, 24, that's divisible by 8. 6 times 8, 48, that's divisible by 8. I'm stretching my maths here now. 8 times 10, I can do that one. 10 times 12, 120. Yeah, that's divisible by 8 because it's 40, 40 and 40. Okay, this is feeling more true. Okay, and you could keep going. And this is not proof. This is just giving me a feel for the fact that this seems true. So I might seems true. Okay. So I haven't proved it, but now we need to think about how do we prove something is divisible by 8. Okay, and we all struggled a little bit with thinking about how something is divisible by 8. What does it need to be divisible by to be divisible by 8?
4 and 2.
It must be divisible by 4 and 2. Okay. Can we take that a little bit further?
Well, you have to be able to divide by 2, then 2 again, and then 2 again.
Yeah. Yep. So that's another way of thinking about divisibility by 8. So if you can prove that it's divisible by 2 and 2 and 2, then that proves that it's divisible by 8. How can you show that 2 consecutive even numbers are divisible by 2 and 4?
Well, the product has to be even.
The product definitely has to be even. Does it have to be more than that? If you've got two even numbers?
It should be factors of 4 and 2.
Yeah, one of them needs to have 4 as a factor and one of them needs to have 2 as a factor. Yeah. What do even numbers? By definition,
Divided by 2.
divisible by 2. So you've got an even number times an even number. So what's that definitely divisible by? More than that? 4. Yeah, if you've got an even number times an even number, then that must be divisible by 4. Unfortunately, it wants more than that. It wants it to be divisible by 8. What can you say about every other even number? What must every other even number be? Pardon? Every other even number. Why, David?
Because
Is that does that make sense?
it's just like, yeah.
Because multiples of 4 must be multiples of 2. So every other one must be a multiple of 4. Therefore, in each pair, there must be what?
One is divisible by 2, one is divisible by 4.
A multiple of 2 and a multiple of 4. Yeah. Therefore, the product is divisible by 8. What's your question, Henry?
Benjamin, I was just saying that, you know, in the pressure of an exam is quite, you probably wouldn't have spotted that.
That's why I don't really like
too long.
proof questions are so, yeah. Is it worth, that would probably take me, what, 15 minutes?
I would be glad it's 2 marks.
Yeah.
I'm not complaining.
Yeah, in some ways, if you look at it conversely, you don't want a 10-mark proof question, and there are very rarely 10-mark proof questions. I don't think there are any. No.
But it's sort of
Which is a
one
long
that
time
you-
to spend on 2 marks.
Yeah, it's one like you leave to the end and then come back to it
Yeah.
if you have time.
Yeah. I would say if you don't see it immediately, don't spend hours on it. Okay. It's for this. Can I show you the algebra? Because lots of you tried some algebra, and this is the algebra, and it's very close to what a lot of you were doing, but you didn't identify in your algebra the even numberedness. So actually, 2m, 2 where m is an integer, is even where m is an integer. Okay, so that's the way of defining algebraically an even number. Okay, and that's fairly standard. Let's just give ourselves a bit of space. So the next number is what? Is 2m plus 2. Okay, the product is 2m times 2m plus 2, which is 4 m plus 1. What can you say about either m or m plus 1? And it's the same leap that we've made up here. Either m or m plus 1 must be, if you've got two consecutive numbers, numbers go odd, even, odd, even, odd, even. So must be even. Therefore, divisible by 8. Okay, and again, that's the key step, isn't it? Okay. Silly? Okay. We'll leave it as silly. Okay, and we'll move on.
I'm really annoyed because I did that and then I took out a factor of 8 and you didn't like that it was divided by 2 and then...
You didn't tell me why it was divisible by 2.
No, as in because I took out 8 as a factor, it was x squared over 2.
But then that doesn't prove divisibility. Yeah, if you...
Okay.
Yeah, if you leave a fraction inside, you're not proving that it's divisible.
That's right.
And actually, you don't know which one of these is the one that you can divide by 2. But you know that one of them must be divisible by 2. Harry, this question bothered you. Are you happy with that? Do you understand it?
Really can't think of it like in the next day.
Okay. I hope we look at the proof questions over time. We look at them first off. We see whether they're easy to disprove. They're the ones you like. If you can disprove something, give an example, disprove it. If you're trying to prove it, write down something in 2 or 3 minutes. If you can't think of anything, move on. Have it mulling around in your brain and you might come back to it or you might not. Yeah. Let's go with that, because I think, and then each paper that you do, hopefully you'll become more familiar with proof and how to do it. Okay. Much more standard question, this one, and kind of some standard answers, some standard things that you need to be able to do. So, show algebraically that f of x is an odd function. I was impressed, and this kind of encouraged me in a way that you are doing some revision, you are working on this. This wasn't a question that you left blank, that you had no idea what they were talking about. Because if you don't know what an odd function is, then you're stuffed here. But f of x equals minus f of minus f. That's the definition of an odd function. Okay, so you've got to prove that. Different. You wrote it's this. Yeah, it's the same thing. Or minus f of x equals f of minus x. Those are the same thing. Yeah. Okay, whichever you think about it. So I'm going to do minus f of minus x is minus x over the square root of 2 plus minus x. And people answered this really nicely. Minus x squared equals x over root 2 plus x squared, and which equals f of x. Therefore, it's odd. Okay. The thing that people didn't answer was the geometric bit. People got really close. I can't remember whether anyone got it entirely. It is rotational symmetry.
The word rotational.
Because rotational symmetry isn't necessarily.
Missing out entire parts.
It's like saying in a rotation GCSE question, can I miss out the origin when I describe a rotation? Yeah, you lose a mark for it. Yeah. So rotational symmetry. And the mark scheme's really specific. It doesn't give any doubt over that. Rotational symmetry. Order 2, people got that. And the thing that they missed, as Benji said, is it's got to be about the origin. Okay. So, Kim, did you miss out the word rotational?
Yeah, I thought about it, but then I thought order 2 explains it itself.
No, they were really specific. You needed those 3 bits to it.
And when it says geometrically, you don't have to sketch it, right?
Nope. No, they just said describe, interpret geometrically. So if it was the other one, if it was an even function, let's just get that out of the way. What would you do to describe
Reflection in the y-axis.
a reflection about the y-axis? Yeah. And minus
Yeah, Johnny, if you had the whole answer,
Yeah.
it's not fun.
minus
F of x
equals
is f of minus x.
Yeah.
Yeah.
f of x equals
F of minus x.
f of minus x. Yeah, I thought you were throwing in an extra minus then. No. Okay, so that's even. Okay. Okay. So part 2, show that the differential of that. This was actually quite tricky. Okay, and the first bit, to get the first 2 marks was easy. To get it rewritten like this caused people some proper grief. Yeah. And this would be one of those ones where you do it, you have a go, then you move on and you don't panic. Okay. Let's have a look and see whether we can do it. But again, the good thing, people were doing the right thing in terms of trying to differentiate this. We've got the bottom times the top differentiated minus, you can use the u and v here, lots of you did that, minus, if you're going to do it without the u and v, you've got to be really clear on the different bits. So minus bottom times top differentiated minus top times bottom differentiated. And given that we forgot when we were differentiating earlier, you've got to remember, so this is 2 plus x squared. At the moment it's to the half, so I'm differentiating, so I'm taking 1 away, times by the power, times by the differential of the inside. Okay, now I realise that I'm doing that all in one go. The principle is exactly the same if you do the u and the v method. When you're differentiating the bottom, some people started with the bottom as being 2 plus x to the minus a half. If you're doing that, you're effectively doing a product. And you could then apply the product rule and it works, but you can't apply the quotient rule. Do you get what you've done? Yeah, okay.
I remember being really confused about which one I should put.
Okay,
I chose the wrong
you could do either, but you can't do both.
one.
Yeah? 2 plus root, root 2 plus x squared squared. Okay, so the bottom's fine. Everyone spotted that goes nice. But then we've got to simplify what's on the top. So we've got root 2 plus x squared minus, let's simplify all of this, we've got x squared 2 plus x squared to the minus a half. Okay, over 2 plus x squared. Okay, and I think most of us got to that point, and we're like, okay, I cannot see how I'm going to get to that answer that they've got. Here's my suggestion. Okay, my suggestion is that I'm going to get the denominators to match. What have I got to do to the top and the bottom to get the denominators to match? What have I got to do? Times it by?
2 plus x whatever to the half.
I've got to times the bottom by 2 plus x squared square rooted. Yeah, I've got to times it by, because I want to get 1.5 2 plus x squared. So I've got 1, so I've got to multiply it by a half. Yeah, I haven't said that right, but do you get what I mean? I'm getting blank faces. 2 plus x squared, I've got to multiply that by 2 plus x squared to the half on the bottom, and then that becomes 2 plus x squared to the 3 over 2. Okay, now I'm going to do that to the top, and I'm going to hope that with a bit of luck, it'll simplify to 2. Okay, let's see. Root 2 plus x squared, and I've got to times this by 2 plus x squared to the half. That's looking good already. That's looking like that's going to simplify. Minus x squared times 2 plus x squared to the minus a half times by 2 plus x squared to the half. That's looking good as well, because I've got to the minus a half and to the half, so that's going to go completely. Yes, Nick?
Doesn't it turn into 1?
Yeah. Times x squared gets you x squared. So I've got this one, that's just going to be 2 plus x squared on the top. This one is going to be minus x squared. And this one is 2 plus x squared to the 3 over 2.
So sneaky.
Because those two joins get
I can't believe
I'm pretty sure I lost.
I'm not saying that's easy, but I am trying to give you some strategies that mean that could you do that kind of thing if you saw it in future?
But I don't. That makes perfect sense. But I just understand why you would times by that bracket in the first place. Like if they didn't say show that.
Oh, no, you wouldn't. If they didn't say show that, you'd leave it like this.
Why is there minus there?
Because we differentiated because that's what
I only got.
I think I lost like 20 marks just
Because it's minor. The formula is bottom times top minus top times bottom.
Was that meant to be a minus?
Why is minus boss by 2 plus x to the half x squared?
Here.
Yeah.
This is the key step, isn't it?
Yeah.
Okay, because I'm ending up, I want 3 over 2. And at the moment I've got 1,
But a square root
so I've got to times by an...
is just a half.
So you've got times everything by that.
So I've got to times everything by that, because otherwise I've changed it. I don't want to change it, I want to times everything by that. So I times it there, and then I hope that the top will simplify. So I'm going to line up the bottom.
But we've differentiated.
I've got it as a single fraction, so that's good. And then I'm going to do something to make the bottom, and then if they're right, and if I've done my differentiation right, I know that the top must simplify to what they're saying.
Okay, yeah.
So why was that
I
minus?
get, yeah.
True.
Wait.
Yeah? Yes.
Why- How does square root of 2 plus x squared equals 2?
No wait. Sorry, that's my fault. It is a half.
Why is it-
Because it's a half.
This is a half,
It's not.
because this is 2 plus x squared to the half, times 2 plus x squared to the half makes 2 plus x squared.
Because the powers, you add the powers on your.
Oh.
Yeah, square root of times square root of is...
Get it?
Yeah. Okay, so that was a bit sneaky, but we could do that. Now then it says part 3. Find the exact area of the region bounded by the curve. Let's go and have a look at the curve again. And the line x equals 1. Okay, so x equals 1 is going to be here. So we're doing a standard integral of this function between 0 and 1. Okay.
Yeah, and then I've got to integrate.
So I'm going to do it up here, just so I can see my graph. The integral between 0 and 1 of x over the square root. You did, you got so close, and then you forgot the final little bit.
Was I supposed to take a half out of it?
Dx. Okay, so let's have a look at that. So we're going to do it by substitution. I think everybody spotted that you've got to do this by substitution. U equals, what's our U going to equal?
2 plus x.
2 plus x squared. So du by dx is 2x. So dx equals du over 2 x. Okay. Now, this is a bit that we're bad at, and I blame myself. Changing limits. Okay, it is often easier to change the limits now than later. I'm lazy and I often leave them in as x limits. It is often much easier when you write down the du, so dx is du over 2x, to think, okay, now I am going to change the limits. And I'm going to change the limits by substituting them into this formula here. So u equals 2 plus x squared. So if it's 0, 2 plus 0 is 2. If it's 1, 2 plus 1 is 3. And it becomes the integral between 2 and 3 of x over, and I'm going to leave that x as x because I can see that it's going to cancel. Somebody rewrote that one as u and then cancelled the u's. That's making it more difficult for yourself. It still works. Over u to the half, or the square root of u. I can then see that that cancels with that. At this stage, I would take the half outside, and I've got half the integral of, and I still haven't done the integral yet. I haven't done the integral. I've got u to the half du. Okay.
If you put the half outside of the integration, what would it be?
Here.
Yeah.
It's the same. You
So du over 2 is that, and then that's left a half, and then you've taken it out.
yeah.
What would it be if you didn't take it out?
Exactly the same. You just leave it in as a half here.
Okay.
You could write a half here or over 2 there.
Put 2 instead of a half.
Does it not become the minus half?
No. If you integrate a constant, it just becomes constant times something.
No, it's x
Because you
1 over
cancelled
u.
the what? Yeah.
1 over u.
So that becomes 1. Oh, sorry. Did you saying minus there? Yeah, I think did I say minus a half and then I didn't write it? Yeah. Sorry. Yes, you're absolutely right. It becomes minus a half. Yeah. Okay. Because I haven't done the integration yet. Okay. I haven't integrated. I've just substituted. I've just turned it into a doable integral. Please, there are a few people that are obsessed with ln. Okay. Ln is only when you've got 1 over u.
With just u.
With just u. No halves, no threes, no anything else. Okay. Because that's the one where you can't do our C2 integration. Our C2 integration. This is a C2 integration now. Add 1 to the power and divide by the new power. Yeah? Ln is only for the one that you can't do that to. It was the one that we did in almost the first lesson of C3. And I think it was Nick tried to add 1 to the power and got 0, divide by 0. And we had this big discussion about whether you could divide by 0 or not.
Probably.
Yeah? Okay. And we said, no, you can't. But ln is only for that one. Okay? We've become a bit ln obsessed. Okay? A few people.
So,
Yes.
how much harder is this question if you choose u as the entire denominator?
With the square root.
I mean, I wrote the question as wrong in the first place, but then I also chose the because then if they
I think it's all right, isn't it?
differentiating was really difficult.
Yeah, the differentiating would be more difficult.
Because that's the same as that.
But I didn't remember.
It just didn't work out very well.
I'm not. This is the ideal way to do it. Can I sit down with you at another time and just go through it with you? If you want to stay at break time, I'm more than happy to go through it. But I think it would work. Yeah, my intuition says it would be work. You've got more difficult integration, but an easier. Oh, actually, don't know. No, it might go horrible. We'll have a look at it. Equals. Okay, so now I'm going to do the integration. So now I'm going to put square brackets. Okay, 2 and 3. I've done the integration. I'm going to add 1 to the power, u to the half, and I'm going to divide by the new power. So I think, Joe, this is where you're getting confused by the dividing by a half. I'm going to divide by a half, which is the same as multiplying by 2. Okay, and then I can see that that half and that 2 cancel, and actually I'm just left with u to the half, and I've got a sub 3 in and a sub 2 in. Notice it says oh no, we're not on that one. The exact area. How could I write this in exact form? Surd form. Root 3 minus root 2. Okay. Okay, this would be a classic example of a question where you were all pretty close. Well, lots of you were pretty close. Okay, and it's about making sure that you get all of those 4 marks and not 2 of them. And most of us got 2 of them and not 4 of them for various different reasons. Okay, I think the exact area thing, I think that will pick us all up 2 or 3 marks. Okay. We were pretty good at this. Part 4, show that. Here, people went kind of 1 over, various people did it in different ways, 1 over y, and you've got to flip this one upside down, is 2 plus x squared over x, and then people squared it, and when I've got that squared, and that squared is 2 plus x squared over x squared, which is 2 over x squared plus 1. Okay, I don't want to spend hours on that. I think there was 1 or 2 people that did something pretty dodgy. Please check what you did, make sure you understand what you did was wrong, and why it was wrong. Okay, yes?
Why would the x squareds not cancel?
Because it's like 2
That's bad.
You know, I know it's bad, but this is like...
Because you're dividing the top and the bottom by x squared. If you divide the top by x squared, you've got to divide everything on the top. If that was if that was 2 times x squared and you divide it by x squared, then yes, it would just leave you with 2 over 1. Okay, but because it's 2 plus, you divide the top by x squared and you've got to have 2 over x squared plus 1.
Okay.
Yeah. Okay. So B then. So last bit of differentiation, bit of implicit differentiation. Again, lots of good stuff going on with our implicit differentiation. Most people remembered the key step to implicit differentiation. So we've got 1 over y squared equals 2 over x squared plus 1. Differentiate. Well, we're differentiating both sides with respect to the same thing, because otherwise we're not doing the same thing to both sides of an equation, therefore it doesn't remain balanced. So we're going to differentiate this side with respect to x, but it hasn't got any x's. So we differentiate it with respect to y, and then times by dy by dx. So differentiate y to the... I'm going to write this as y to the minus 2. I can't do it. I'm going to make a mistake. So that's 2x to the minus 2 plus 1.
I forced it.
So differentiate that. I'm going to take 1 away from the power. So I get y to the minus 3 times by x squared goes to 2x. So minus 2 y to the minus 3. Equals, times dy by dx, that's the crucial thing, equals, differentiate this one, minus 2 is minus 4x to the minus 3. Notice the 4 is not with the minus 3, the 4 is not underneath here. So, a few people got a little bit muddled, so we're going to keep that as minus 2 over y cubed, dy by dx, to get rid of the negatives because they confuse us, minus 4 over x cubed, not minus 1 over 4x cubed as some people wrote. So dy by dx, then I think it's fairly obvious the minuses go, one of the 2's go, you get 2y cubed over x cubed. Explain why this expression cannot be used to find the gradient of the curve at the origin. When x equals 0, dividing by 0, not possible. Now, I think let's have a look at the mark scheme, whether they required you to have, sometimes they require in the mark scheme you to have got a previous method mark to allow you to get that mark. Okay, they don't just give away marks.
Wait, so
Yes?
how have you gone from minus 2 over y3 dy over dx to the line below that?
This one to this one?
No, the next one.
To there?
Yeah.
Okay, so I've multiplied both sides by y cubed.
Yeah.
I've divided both sides by minus 2.
Oh, I did.
I've cancelled the 4 and the minus 4 and the minus 2.
I just didn't see how you did that.
Yeah, you happy? Yeah. Okay, that pretty much, in fact, that exactly brings us to the end of the lesson. What question was that?
8.
I don't understand.
8.
We just got 9 in there.
I got this right, but I did not have a 4 in there.
Okay. You didn't have a 4.
No,
You should have had a 4 somewhere.
no, because 2 over x squared, because you've like flipped it.
It goes from minus 2
Wait.
cubed over 4 minus 4
Don't worry,
Have I marked it wrong?
you may have.
Count yourself lucky. Okay, if you want to stay and ask some questions, by all means stay and ask some questions. We've got the last question that we will finish off next week. With this one, are there any? I will have a look through it. Part 3. Have you circled that to say that that's a?
So I didn't
Oh, that was a long
I
one,
didn't
7
finish
part 3.
question 7.
I got it in untold.
Is that what they were?
Well, that's cheating.
So I actually didn't
It's called assisted guidance.
really know.
Okay.
But,
If guys, I'm happy to. I will look at the bits that you want me to look at. It's the kind of prep that's actually quite easy to mark yourself. But if you want to leave it with me, I will look over it. Particularly if there's something that you think I couldn't do that and I need some help. So just leave it there.
So part 3 is good. Another one.
Wait, did you want it or did you not want it?
Has everyone done it?
Later on.
Yeah.
Yes.
There it is.
Okay. So if you want me to look at it there. Otherwise, I will assume that you've done it. Okay. I'm kind of your.
So do you want mine? I've marked mine.
No, that's
Yeah,
fine.
Okay.
kind of.
We finished it.
We worked together.
Yeah. We
Did you
finished
work
it
it out?
together.
Yeah, it was very difficult. Can you
Yeah,
show me how
let's-
to expand? Actually, it's fine with the
Are you saying that?
differentiation.
Yeah. We taking C1 and C2 because I'll be really quick.
Yes.
Do you
Can I
think
borrow them, please?
with 77 like 79?
You should probably
retake
retake
something.
I'm trying to figure out how to expand something.
So I was saying Mrs.
Miss Armand Smith is the one that is coordinating all the
Okay.
retakes. I would go and see
So
her.
see how okay. Sure.
I did the prep, but I didn't finish question 7. Everything else I know I've gotten right and I'm happy with. But when I finish question 7, if I'm not okay with it, can I put it? Yeah.
I forgot.
Forgot what?
How to expand this.
What subject are we in here? This is. By expanding that, do you mean using?
No, not using not C4 stuff. But like this has come up before, especially when you rearrange the equation to find x in terms of u. It's come up where and it's always there's always a square root somewhere, and it's x squared, and so you end up with an expression that's u something to the half, because you've square rooted it, and then you have time to buy something else, and I don't know how to. Let me check my paper. I don't know if that's what it actually came out as, but it was just a very awkward thing to try and expand. I actually think if I'd written it properly, it would have cancelled out, but I didn't. So it didn't cancel. Yeah.
See. It's that, but that's not necessarily going to help you.
Why is it?
So if I put it inside the square root, it's
Oh, okay.
it's u to the 4.
Yep.
But that's not necessarily going to be nicer.
No, I just wanted to know how to expand it because that has come up a few times where you then have to integrate.
So there isn't.
No.
You can't go. This you can't go. This is u to the 1 minus 1 to the half times u squared. That's bad.
Yeah.
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 So that doesn't, and I wouldn't say that's necessarily where you would go with that. That's more common.
Yeah. And then
So u to the 4 minus 2u squared plus 1, u to the half, u to the 4.5 minus 2u to the 2.5 plus u to the half,
and then integrate that.
and then you can integrate that. That's
Yeah, I think that's the one that usually comes up. This one.
yeah.
It's just because I didn't write. I wrote 2 instead of x because of the question above. I just wasn't. I'm sorry. I wasn't concentrating. Like I knew what was happening, but I wasn't concentrating enough.
Well, and if doing that mock, if all it makes you realise is actually how important it is to stay really, your brain needs to be really on it. You can't kind of distractions and all the rest of it make it really tricky.
Okay. Next time we do a mock, can we do it in your classroom, please?
Did you not like
It
it?
really, even Maria was saying like it just threw off completely.
But really interesting because your exam won't be in my classroom.
No, but I'm used to the assembly hall, and I'm used to this classroom. I think I get used to like mechanics in general. That classroom is not really associated with like happy
positive
flowing
vibes.
floors.
Is mechanics
If it
not
was in
going
Miss
well?
Fox's
Are you-
classroom,
are you
I would
not-
be fine.
Are you not?
No, it's getting better. It's been I don't know if we go back. I don't know how well I'll do, but the things we're doing now, I understand.
What are you doing now? Projectiles?
No, we just finished projectiles. We're doing
Forces?
yeah, we're doing things on a slope. We've just finished things on slope, and then we're doing like tensions, things being yeah. It's getting better though, because I think with mechanics, once you get you'll wrap your head around the concepts.
Yeah,
And then
I agree.
understand the
I agree.
fundamentals.
And actually, those are the important chapters: the projectiles chapter and the forces chapter. If
Yeah.
you get those ones sorted, you're sorted.
Yeah, because for me they kind of bring everything together, like Suvad and everything, and now.
They do. Yeah, you're absolutely
Yeah.
spot on. Yeah, let's just save that.
Okay. Thank you.
Um,
From like minus a half ln m to like minus m over 2 ln m. I don't know, I'm just so confused. It's
Because that's what S can come in with.
Okay. So if I just go back and just say, okay, we know that x coordinate is minus a half ln m. Yeah, because of what we've done earlier.
yeah, but I thought we're subbing in into the equation of y equals to mx.
Yeah, so the y coordinate, so the x coordinate is minus a half ln m.
So,
So
wouldn't that
at P,
multiplied by,
so y equals, what are you going to say?
I thought it was going to be minus a half ln m times e to the power of minus 2.
Minus a half ln m. Can I take us back a stage? You're right, times m.
Yeah.
Yeah. Now, I've got to prove, before I can know what m is, I've got to prove m is e to the minus 2.
Yeah.
Yeah?
Yeah, so we got that.
So assuming that m is e to the minus 2, we've got minus a half, the x coordinate, ln e to the minus 2, and the y coordinate is minus a half ln e to the minus 2 times e to the minus 2, which is minus a half times minus 2 times e to the minus 2. which is e to the minus 2. This one is minus a half ln e to the minus 2, which is minus 2, which is going to give you 1. So you've got x is 1, y is e to the minus 2.
Yeah.
Okay, and the other bit of that is you've got to prove that. Well, that you get by setting minus m, that gradient, equal to the gradient that we've got over here, ln m plus m. Divide through by m, we get minus 2 equals ln m. We get m is e to the minus 2.
Yep.
Yeah?
Where did the m then m plus m come from?
So that was this gradient from the previous bit. M ln m plus m. That gradient, the gradient of the tangent, has got to equal minus the gradient of that line y equals mx. Yeah? Okay, then it said find the exact area of the shaded region between the line OP and the curve. Okay, so we're integration. We're integration between, in fact, let's just go over here. So we're going to integrate between 0 and 1, because we now know that this is 1. X e to the minus 2x dx. Yeah. So, how do we do that integration?
Integration by parts.
Integration by parts. And which one's going to be which?
U equals to x, and then du by dx is 1.
Brilliant. U equals x, and dv by dx equals e to the minus 2x, the other one. Yeah? I think you said u for both of them in the end. Did you? Or did you say it right? Can't remember. V equals, so I've got to integrate that to get v. How do I integrate e to the minus 2x? 1 over minus 2, so minus a half e to the minus 2x. Those should be standard things that we are happy with. And then du by dx, that's the easy one, equals 1. Okay, so I'm now going to put, happy if I keep going? Yeah. So we're now going to do u times the integral of v, which is, or times v, which is minus a half e to the minus 2x. I've done the integral for that one. Minus the integral of the derivative of the first, 1, times this horrible thing again. Now, I'm going to take the minus and turn that into a positive, because that makes my life easier. A half e to the minus 2x dx. I'm not going to sub anything in at the moment. I've now got to do this integration. Well, this is a positive, a half. Then I've got to integrate e to the minus 2x again, which is minus a half e to the minus 2x. Between 0 and 1. Happy? So I put sub 1 in, I get minus a half e to the minus 2, minus subbing 0 in, minus minus 0. plus, or in fact, minus a quarter, sub 1 in, but I've dealt with all of those, e to the minus 2, sub 0 in, got to be careful here, e to the 0 is 1. So I've got, altogether, I've got minus a half and minus a quarter. So I've got minus 3/4 and I've got minus a quarter. So I've got, sorry, that's a minus 1. So I've got minus a quarter, so I've got 1/4 minus 3/4 e to the minus 2, which I don't know whether they give you that and ask you to show it, or whether it's a... No, they don't. And just, you've got to work that out. Okay. We're not quite there. What area is that giving us?
The entire thing.
That's the entire thing.
So you have to minus it.
So that gives us, if we look over here, that gives us all of this area, and we've got to minus that triangle. Well, that triangle, how high is that triangle? The triangle is a half the base, which is 1, times the height, which is e to the power minus 2. So the area of the triangle is e to the minus 2 over 2. So we've got to take a half off that. So we've got to take a half of e to the minus 2. So the shaded region equals 1/4 minus 3/4 e to the minus 2 minus e to the minus 2 over 2, which equals 1/4 minus 5/4 e to the minus 2. Done. Happy. Okay, any questions on any of that?
Where did the minus 0 and minus 1 come from?
So we're subbing in, we sub in 1 minus subbing in 0. And subbing in 0 doesn't always give you 0. Subbing in 0 to this one does, because you've got 0. But subbing in 0 into this one, you get e to the 0, and e to the 0 is 1.
Okay, yeah.
Good question.